This question says that we are given a collection of intervals and we need to merge all overlapping intervals. So how they have defined an interval is vector of integer, which means like this vector has just two entries. One is the start and one is the end. Does this make sense? We have to merge all the overlapping intervals, and these are inclusive brackets. So 1, 4 and 4, 5 are overlapping. So any suggestions, ideas how we can solve this? Sort by second element and then okay. Still like ideas. Compare first of one by second of other, and like what is this one and the other, like how will we compare
I
which?
think we can sort all of them on the basis of the first element, and then match this. Check that the second element of the the vector we are still at like the current position. Compare with the next. If the next first element is less than the second element of the previous element, then we can merge that.
Correct. So that is one possible solution. So did everyone understand the solution?
Ma'am,
So
could you please repeat the question one time?
so this question is, you are given a vector of vector. So this vector has, so every element you are given a vector where every element has two fields. One is a start field and one is an end field. It's an interval basically. There is a start time and then there is an end time. We need to merge all the overlapping intervals. This is the question. Now, the solution that was proposed was, let's say we sort this array based on the first element. So, if we sort this array based on the first element, what do we get?
Ma'am, how does the overlap actually? Like,
Overlap
could
is
you explain
yeah, sure.
example one?
Yes, sure. So you have an interval as 1, 3 and you have an interval 2, 6. So so you have this line. You have one interval which is from 1 to 3 and you have another interval which is from 2 to 6. Now what you want to do is, if and let's say you have another interval which is 7 to 8, 9. So let's say you had another interval which is from 5 to 9 and just from 5 to 9, let's say.
Okay, I
You
got it.
just 1 second, let me explain it. So let's say you had another interval which is from 10 to 11. So now this 1 3 overlaps with this 2 6. This 2 6 overlaps with 5 9. This 10 11 is does not overlap with any other interval. So we need to merge these three intervals. So basically we'll merge this interval with this interval 2 6, 1 3 with 2 6, but then 2 6 has to be merged with 5 9. So we'll have to merge all of these, like these three intervals, and this 10 11 will remain separate. So we'll have an interval from 1 to 9 and another interval from 10 to 11 in the end. Does this make sense? The question is clear to everyone now? Right. So that's what we want to do here. So for this case, if we merge 1 3 with 2 6, we get a 1 6. 8 10 does not overlap with 1 6, so we have an interval 8 10. This 15 18 also does not overlap with any other interval, so we have these three intervals in the final answer. And as I mentioned, this is like a special case, like the this number is inclusive in both the intervals. So if you have a number which is inclusive in both the intervals, you merge that interval. So that is what the question is. So how we are going to solve this is, if we sort this array based on the first element, if we sort this array based on the first element, this is exactly the array that we will get. So we are given a sorted array based on the first element. Now the algorithm that was suggested was, like, if we have this sorted array, what we do is we traverse over this array, we check every interval and compare. So let's say we create a new array. This is my answer array and this is my input array. So this answer array will have the merged intervals. What How we'll do this is, so let's say we just had one interval in our input array. So answer array will have that one interval. Let's say it has the first interval from the input array. Now if we move to the second interval in the input array, we compare it with the last interval in the answer array. So we take the start time of the input interval and the end time of the last interval in the answer array. We compare these two. So this 2 is smaller than 3. So these two intervals are overlapping. And this array is sorted based on the first element, basically starting element. So we know that the starting element in this interval cannot be greater than the starting element in this interval. Does this make sense to everyone? Right. So we can modify our end element for this interval. We'll take the max of the current end element and the max of the end element in the current interval that we are processing. So this will become 6. Now we move forward and we encounter this 8 10. Now we compare this 8 with 6. 8 is greater than 6. So this does not overlap. So we add this interval to our answer. Now we move forward. We get this 15, 18. Now we compare this 15 with 10. We check, so there is no overlap. So we add this 15, 18 to our answer. Any doubts? So Saurav, question was, do you understand the question?
Ma'am, I haven't.
Sorry.
Okay.
So this is the question. We are given some intervals and we want to merge all the overlapping intervals. How we are doing this is we are sorting it based on the first element, the starting element, and then we'll do a run over this array and we'll compare, we'll create another answer array and we'll keep on adding intervals in that answer array. And while doing so, we'll keep on merging the intervals also. So let's look at the code, it will become more clear.
Okay.
Excuse me. इस पे push कर दिया. Right. So first So, so this will work once this interval array is sorted. Now, how we can sort this is we'll use STL sort for this. So, I'll write sort intervals dot begin comma intervals dot end. Will this alone work, or do I need to do something extra?
We need to add an extra function comparator to sort
No,
this type of.
This should work.
right. This should work. So what happens for 2D arrays is, so even if you don't specify a comparator function, what the sorting algorithm will do, it will sort this 2D array. Basically, this is a vector of vector, right? A vector of vector is like a 2D array. So this is like the first column and this is like the second column. So it sorts a 2D array based on the first column, the 0th column of the array. Does it make sense? If we don't provide anything comparator function, then it sorts it based on the first column of the array, which is the 0th column. In our case, our starting element. That's what we wanted. So this will work.
Ma'am, I had a doubt.
Yeah,
For the first element, we can simply use the normal sort function that we were using, right? So if we need to directly compare the second element, so can't we do it the way we used by greater int? Actually, we use it by the use of function comparators. So
I did not get the
why
question.
can't we do it by using Ma'am, ma'am, I actually read it somewhere that for comparing the second element of a 2D array.
Right,
Okay, so like we have to use the function comparators. So
correct,
there we do the comparison and then we return it there. So why
correct.
can't we simply use the greater int like the ones we used in case of 1D arrays?
So greater int is so okay. So anybody wants to guess what will happen if I specify this greater int here?
And this should provide the first elements in the decreasing manner, but it does not do so.
Okay, let's try. So can anybody like understand this error? So this greater int is basically expecting an int argument. And what you are giving this is a vector of int. So this is a vector of int and it is expecting an int argument.
Okay, ma'am.
Does this make sense?
Yes, ma'am.
That's why this will not work. I don't know if it takes a generic type. Let's try with vector of int. I have never tried it. I don't think it will work. Okay, it works. So it so basically this is the type of the element. So it takes a generic type. So here when I provided this vector of int, so it took this vector of int and it sorted based on the 0th column. So it will always sort based on the 0th column. It will so that's what the default argument is. If you are trying to sort a 2D array, sorted based on the 0th column. That is your source of truth. That will not change. This greater just says sorted in descending order. Does this make sense?
Yes, ma'am.
Yes, Pranav. This is a part of STL. This is a function that STL provides to sort any so basically this is a comparator function that STL provides to sort your array in descending order. I mentioned this yesterday also. While sorting it in descending order, we can use this function. So now what happens, like what if I want to sort it on the second column? How do we do that?
I think that needs comparator.
Correct. So we'll have to create a custom comparator function. What will be the arguments for this function? Well, what is the type of these A and B? Right. So what we are doing here is we are sorting this array, this vector intervals based on the second column now, which is the second column, basically the first indexed column. So if a of 1 is less than b of 1, put a first. Now a is a vector. A is this entire row. So put this entire column first, entire row first, entire interval. Does this make sense? Is there anybody who does not understand this? Greater, right? No, we still want to sort it in ascending order. We don't want to sort it in descending order. Or do we want to sort it in descending order? So how will this work? Like, how will we solve this question if we want to sort on the second column, the end interval? Guys, you need to speak, otherwise you will not learn. Then we return false. No, we don't have a of 2. Second column means like it will be indexed 0, 1, right? Second column means a of 1.
Ma'am, can you please explain the logic behind this once again? Like you have used DP here, so like
Which logic?
the one inside the for loop which you have used
The logic inside
for
this
the
for loop.
overlapping. Uh,
So what,
yeah, the if statement.
right. So what we are doing is we sorted this array. Now I have all the elements sorted based on the starting the start time of the intervals. So this was the logic that I used to
Yeah.
implement this function. This was not based on the ending element. This was based on the starting element. So if I sort this array based on the starting element, and then I traverse this intervals array, how we do it is, so I take this interval 1 3. Now I have sorted all the intervals, all the subsequent intervals. So I start comparing this 1 3 interval with the next interval that I find, which is 2 6. So I see that this 2 6 overlaps with 1 3. So I make this one interval, which is 1 6. Now I check the subsequent interval, which is 8 10. So this does not overlap with this. Now, what that means is if this interval 1 6 does not overlap with 8 10, so it will definitely not overlap with all the other intervals that come after 8 10. Is this statement clear to everybody? That if 1 6 does
Yes,
not
ma'am.
overlap with 8 10, it will never overlap with any interval that comes after it, because we have all the intervals sorted based on the starting time. So we put this 1 6 into our answer array. So this 1 6 was already in our answer array. How this 1 6 was already in our answer array? We had this 1 3 in the answer. We compared it with 2 6, and I found that there is an overlap. So we incremented the end time of this interval, the last interval. The last interval that I had put in my answer array, I incremented the end time for that. When I found that there was no overlap, I come to this else and I push the interval here. Now, if there is an overlap, I will be modifying this interval that I had put last in this answer array. Does this make sense now?
Yes, ma'am.
Okay. So let's come back to this. So how will we solve this question if we wanted to sort on the end time of the interval? So Pranav, if we sort it on second column in descending order, you will get 15, 18, you will get 8, 10, 2, 6, and 1, 3. Now what you are doing is you want to compare the starting time of the next interval with the end time of the first. Um, I don't quite understand what that means. Let's see. So you want to sort it like 15, 18, 8, 10, 2, 6, and 1, 3. Now what you want to do is you want to compare the starting of the next interval with the end of the first. How will this work? Starting, like, end of this interval is definitely like smaller than the end of the first interval. Starting will definitely be smaller than the first interval. If we compare start of the first with the end of the second, if we compare start of the first with the end of the second, um, that is just too complicated an algorithm. That might work, but we'll have to see. Any other ideas? What if we sort like in ascending order based on the second column? Then what do we get? So yes, in this case we get the same output. Let's take another example. So like it's not about the output, it's about the algorithm. How do we like what will the algorithm be? Like if I sort it on based on the second element. So what might happen is this could be one of the possible test cases then. Right. This could be one of the test case. We could have this 3-6 before 1-6. So we'll have definitely have to modify our algorithm. Does this make sense? This could be one of the possible test cases. So we need to modify our algorithm. How will we modify our algorithm? So basically what changed in here? So the thing that changed is we could be having a start time, like smaller start time in the end. Like this 3-6 overlaps with this 1-6, but this 1 is smaller than this 3. So let's say I add this 3-6 to my answer, and then I find this 1-6 overlaps with my 3-6. I need to modify this 3 also. Then I find this 2-8. This could be, let's say this is 0-8. Now this 0-8 overlaps with this 1-6. So I need to modify both of them, 0 and 8. Correct. So we need to compare the first field also. So that is just adding to the complexity. But I wanted you to understand, like, if you think it this way, this can still be solved. It's not like this cannot be solved based on, like, if we sorted using it, if we sorted on the second column. Correct. We need to add this condition also here. Gaurang, I explained it yesterday. So this compare function is, we are not calling this function here. It acts like a pointer to this function.
Should
So
we take the minimum? You're taking max in both the cases.
yes, sorry. This will be a minimum. sorry, this will be a minimum. So this compare function is not a call for this compare function. This is like passing a pointer of this function to this uh, to this to this library, this sort function. So we are making a call to this sort library and we are passing a pointer to this function to this library. So do we need to take care of any other cases? Are there any other cases that needs to be taken care of? So we made an assumption here. Will this be true for the starting element also? So what was the assumption? The assumption was if I sort it in ascending order and this 1 6 does not overlap with this 8 10, it will definitely not overlap with all the subsequent elements. Does this assumption, like, is this assumption true in this case also?
And could you repeat it?
So if this 1 3, if I merge these two intervals, it becomes a 1 6. If this 1 6 does not overlap with this 8 10, can I say that it will not overlap with any other interval that comes after this 8 10? Right? So that is an invariant that we have set when we were sorting on the starting element. Now we are sorting on the ending element. So can we still say this? Does this still hold that, let's say I have an interval AB here? Can I still say that if this interval, so let's say, so can I still say that if this interval does not overlap with this AB, then it will not overlap with any other interval that comes after it? No, right? So how? Let's take an example. Let this be 4 9. No, sorry, 0 8. Let this be 9 16. And this to be 7 17. So what happened in this case is we had this 0 8 till here, and then we compared it with 9 16. It does not overlap. We add our 9 16 to the answer. Then we find the 7 17. This 7 17 overlapped with this 0 8. Correct. So, but there is something else that will also happen in this case. So this 7 17, if this element overlaps with 0 8, then it will overlap with all the other elements that come after this 0 8 in the answer array. Does this make sense? That if there is an interval 7 17, if there is an interval AB which overlaps with an interval which comes in between the answer array, then it will like overlap with all the intervals that come after it in the answer array. So we need to take this assumption also. So we need to take care of all the cases. Just by sorting based on the second element, our life became a little difficult, right? Ascending order based on the second column. Our life became a little difficult just because we wanted to sort it on the second column. So do you time complexity? Yes. So every time we'll be going back, we'll be like checking all the intervals that were there and we'll be like merging all those intervals. Hmm. Right. So now what happens when we start from the last? So we say this element, then we merge it with the previous element, then we merge all of it with the previous element. So basically, now the time complexity remains the same. Does this make sense? So, so just because like when we sorted it based on the starting element of the interval, we moved from left to right. When we are sorting it based on the ending interval, ending point of the interval, we are going from right to left. Complexity remains same, but like the algorithm is completely different. So does this make sense to everybody? Right. So I'll give this as a leave this as a homework for you guys to write this code for this uh, like from right to left when we sort it on the second column. I have shown you how to sort it on second column. You just need to write this for loop. Is this fine with everybody? Right. Let's move on to the next question. Guys, just go through the question. This is almost the same question. So what this question says is, this question says that you again have a set of non-overlapping intervals and we need to put a new interval in this set and then we need to merge the intervals. And this question says that the intervals are initially sorted according to the start time. So how we can approach this problem? This is like exactly the same problem that we just solved. Correct. So what we'll do, we'll traverse from left to right in the interval array. We'll compare the starting point of the new interval with the last point of every interval in the interval array. If we'll find the correct position for that interval array and we'll keep on merging the intervals like so basically so only the new interval can make the overlap happen, otherwise there are no overlaps. So either it will not overlap with any other interval, then we'll just find the right position, we'll insert this interval. Otherwise it will overlap with certain some x intervals, and we'll have to merge those x intervals, and those x intervals have to be consecutive intervals. Does this make sense to everyone? Can we use binary search to find the position after that we check the overlap? Yes, we can do that. But again, like while you will be like merging the intervals, you might actually be taking off end time. But yes, that is one optimization that you can make.
Ma'am,
Yeah.
can we write an algorithm where, for example, in this example, we can just find, like, for example, 3 is greater than 2 and 5 is less than 9, so we can insert it there and then just do what we did previously for the other code.
Yes, that's what we want to do, but that's exactly what we want to do.
Okay.
But like if you insert in the middle of an array, it takes O of n time.
Okay.
So it's just that, like, let's say the question was just to find the right position, then you should definitely use binary search. You should definitely not like search it linearly in the intervals array. And like, let's say if instead of a vector you were given a linked list somehow. What is the new interval added? I did not get the question, Karan. This is a given interval. This question is asking you to add the interval. It is a part of the input. That's what the question asks you to add a new interval in the intervals array. Yes, for linked list, we cannot use binary search on linked list, so we'll have to go linearly only. So yeah, so do you guys want me to write the code for this question, or do you want to write it yourself first and then maybe we can discuss it?
Ma'am,
Yeah.
can't we just push back the new interval into the interval vector of vectors? Then we will again sort it by the starting index, and then this question will become similar to.
Correct. And what is the time complexity for this algorithm? Correct. So the time complexity for this algorithm will be n log n, because you are trying to sort n is where n is the size of this intervals array. So we are basically like putting a new element in the intervals array and we are sorting it again, and we are applying the previous questions algorithm. That will definitely work fine. So, and what is the time complexity for the previous algorithm that we discussed? Like if we find the correct position, if we put it there and then we merge all the intervals of n, right? So does this make sense, guys?
Ma'am, can you repeat that once?
So did you understand the n log n time complexity because of the sorting?
Oh, no, that's the part that I wanted to repeat, the n log n thing.
Okay. So what we want, so the other algorithm that is suggested is, so if we put this new interval, if we just push this new interval into this array, this intervals array, and we sort this intervals array, then the question becomes what we just solved, the last question that we solved. You
Okay, so not inserting it at a particular position, just push back.
just push back, yes.
Okay, got it.
right? So do you guys want to take this question as a homework, or do you guys want me to write the code for this? I think you can take this as a homework since we have already written the code for the last question.
Ma'am, could you please repeat the first algorithm?
The first algorithm.
I
So,
mean, that you explained first.
okay. So let's say this was our input and we want to add a new interval which is 5, 7. So if I want to add 5, 7 to this interval array, what will I do? I will start traversing from the left. I will check this 5, 7 does not overlap with 1, 3. 5 is greater than 3. I move forward. 5 is greater than 6. No. So it overlaps with this. So should I put this interval before 2, 6? No, 2 is smaller than 5. I move forward. 8, 10. Does this overlap with 8, 10? Yes. 5 is smaller than 8. I put it here. Now, this is again this last problem itself. This is a sorted array. It's just that it is already sorted. So I don't have to sort it again. So this is a sorted array based on the starting element, and I need to merge all the overlapping intervals. STL command to insert an element in a location. Yes, there is. So you can like insert an element in a position in vector. Like if this is your vector p, then you can use this function v dot insert. But this also takes of end time. This will shift all the elements towards the right. Code to define iterator. What does this mean?
But then you have to even remove those segments and then add it, right?
What do I need to remove?
Like if you have to like add and insert a like like 1 cross 2 element into the array, you have to like remove all those elements which are intersecting and then add a new element, right?
So we are taking the, so you can take this approach. We are taking the other approach. So,
Okay, okay.
or you can take this approach also. That's also fine. So what I said that I'll add this element first and then I'll run the previous algorithm that was there. I'll just not sort it.
Okay.
But you can do it this way also. You can iterate through the array first. You can find all the overlapping intervals and you can just put the final interval later on.
Okay.
Let's solve some more questions.
Ma'am, could you explain again the n log n part? I didn't understand that properly.
N log n part. No, Tulika, why will it be n log n finally? Like we did not sort it. We are traversing through the array 2 times. That's it. The array is already sorted. We are just putting the new element in the sorted position. It will take O of n time. Which n log n algorithm? So n log n algorithm is nothing. It's just that. So what was the last question? Can you iterate the last question for me, Shashank? The last question that we solved.
That was, isn't that also like order of n only because you're comparing like each element and merging and then moving on.
Right. And we did something else also in the last question.
Mm,
So we sorted this interval array here. This sorting algorithm takes n log n time. So whenever you are sorting an array, it takes n log n. So no matter what you do here, the complexity for this algorithm will be n log n. So yes, once we have this array sorted based on the starting element, then it takes O of n, or the ending element, then it takes O of n time.
What is
Now,
the homework you gave? I forgot for the first question. What is the homework you gave?
sort it on the second column and then write the algorithm for this.
Okay, sorted ascending and then sorted according to the second column.
Yes.
Okay, okay.
So in this question, one solution is you just push back this new interval to the existing intervals array. You sort this array and make it so you just push back this intervals array, the new interval in the intervals array, and now you have to solve the last question. You are given a random array which is not sorted based on any index, and you need to merge all the overlapping intervals. Does this make sense now? Yes, pushback adds from last. Putting an element in the end. Okay, then I'll move forward. What the कोड फोर्सेस नहीं चल रहा है क्या? This is the next question, guys. Just give it a read. So this question is very simple. This question just says that you are given some points and diameter is equal to max minus min. So we are given some points and we are given the maximum allowed diameter. So we need to remove the minimum number of points so that the diameter of this set, basically max minus min, is less than equal to d. Is this question clear to everyone? This is a very easy question. So I'll just go through the solution. So okay, anybody wants to like chime in, like what will be the solution for this? Like the first thing that comes to your mind. Right. So we need to sort first because we need to find the maximum and the minimum. So one way is I can go through the entire array. I can find these two elements. I'll find the diameter. If the diameter, if max minus min is already less than equal to d, then I don't need to do anything. But if that is greater than equal to d, then I need to decide somehow how to remove elements, and those elements can either lie on the like minimum side or the maximum side. They cannot lie in the middle. Like, it does not make sense that if I have 1 2 3 4 5 6 7 8 9 10 and I remove 5 and 6, the diameter still remains the same. Does this make sense?
I mean, if it's only greater than d, right? If it's equal to d, it's fine, right?
Yes, if it is equal to d, it's fine. So does this make sense? So I'll not solve this question. So this was just to give you a hint of how you can use sorting for this. I'll put it in the practice problem. You should solve it because this is a very easy problem actually.
Ma'am, could you like scroll down a bit?
Sure.
Ma'am, in that example, 1, 3, 4, 6, 9, 10, you have to just remove 6, 9, and 10, right?
6 9.
And could you repeat the algorithm?
I did not tell the algorithm actually. I want you
Okay.
to solve this yourself. I just wanted you to know that you will need to sort the array.
Can you please repeat the hint that you have given for this?
Okay, let's solve this question here itself. So, um, so what happens when we sort this array? Let's say we have this input 1, 3, 4, 6, 9, 10. We sort, this is the sorted input. This is what we get. Now the maximum diameter that is allowed is 3. So either I can start removing the elements from the starting or I can start removing the elements from the end. So one way of doing it is you do both ways. You start some elements from the starting and you keep checking the maximum diameter, and you keep a count of the number of elements that you are removing. So this is one way of doing it is. Let's solve another question now. So let's discuss this time complexity when we will discuss the solution completely. Try this question first yourself. I don't want to solve a easy question for you. Guys, read through this problem, then we'll discuss this problem. So what this question says is, you are given three numbers, n, the number of exams, maximum grade that you can get in this exam or in any exam, and the required average that you need to pass to get the scholarship. So now this question says that you have got this grade in, so this is like one exam, you got grade 5 in this exam, and you need to write 2 essays to increase this grade by 1 point. Now you want to write minimum number of essays but still want to get the scholarship. So how do we want to approach this problem? Guys, sort on basis of essays. Number of essays we can write by sorting base. Right. So if we sort on based on, so what happens is either we can, so we have again, so this is like an interval. So the first element of the interval says you, like, tells you your grade. The second element in the interval tells you your the number of essays that you can write to increase that grade. Now if I want to increase, I want to minimize the number of essays and I still want to increase the grade. And no matter, so for these two test cases, if I write one essay here, I get a 4 pointer, and if I write two essays here, I get a, so if I write two essays for this particular course, I get a 4 pointer. If I write two essays for this particular course, I get a 5 pointer. So I would rather write two essays for this particular course, right? Is this clear to everyone? So that's what we want to do here. We want to sort it based on the number of essays that we want to write. Like we have to write to increase the grade by 1 point in that particular for that particular course. Does this make sense? But grade can't exceed 5 exactly. So this is, so obviously if you have a 5 grade for some course, then you cannot increase that grade, so you need to move forward to the other course. So you will need to take care of all those corner cases. Let's see the code for this. We can write the code, like some pseudo code for this, and then I leave it for you guys to solve this question. Let's write the code for this. This is the function that we want to implement. Now, first thing, what do we want to do? We want to sort based on this essays. So, is it a good choice to have two different vectors, one for the grades and one for the essays? I did not get your suggestion, Sakshi. Like, take average of each course. What does that mean? Mm. No, I did not get it. Try doing that, like whatever your suggestion is, and then we can discuss it later also. So it actually does not matter if I have two vectors or if I have a vector of vector. I need to sort these grade based on this essays. Do I have a way of doing that? We can write a comparator function to sort these grades based on this essays. So how we can do that is, so this will directly not work. I will have to find what- the index corresponding to this A for this essays, and then I'll have to compare those two elements. Does this make sense? You remember we solved a question yesterday, we in the last, where I had put an index as vector, and then we had solved one array based on the other array. Do you remember that question? So we need to do something exactly of the sorts. It's just that it is a little harder to create a mapping between the elements of this grades and the elements of the essays. So it's better to have a vector of vector. So I have this, now what do I do? I have this int A and int B. I have this essays array. Now I need to check if the essays, number of essays corresponding to this A and B is larger, like number of essays corresponding to this grade A is smaller than the number of essays of like corresponding to this grade B. How do I check that? Like if all the elements in these two arrays are distinct, then we can check that. Otherwise, there is no way we can check that. So we cannot write a sort function based on that. We'll need to have a vector of vector. Now let's say my second element was the assay. So what I'll do, I'll create a compare function here, and this compare function will sort it based on the second column, the essay column, and it will sort. So do we want to sort it in ascending order or descending order? Right. So we sort this based on this. Now we want to find, like, now what do we want to do? What will the algorithm be? How many grades? Initially, I want to check how many grades do I want to actually increase. How do I check that? Right. So this total grades mean the total number of grades that I have till now. So, and I want this average grade. So if I multiply the average grade with the input size that I have, does it give me the total number of grades? So basically, number of grades that I needed plus the grades that I have till now. If I divide it by the average grade, just 1 second guys, I also got confused a little. So this is the average grade that we want to get. What does this mean? This, right, we want every subject to be no, Karan, that is not essentially true. Like you can have a 5 pointer in some subject and you can have a 1 pointer in some subject, and you can still have an average of 2. Like let's say your average grade was 2, you still have it 2 while you have a 1 in one subject. So average is basically sum of grades in all the subjects, right? Divided by the total number of input size, right? Divided by the total number of subjects. So let's say so this average is equal to total grade sum of my grades divided by total number of subjects. So this is the definition of average. Now if I multiply this n with this average, I get the sum of grades that I want to have. So this number of grades, like if I subtract this total number of grades that I have till now from this quantity, then I get the number of grades that are needed. Does this formula make sense for everyone? Right. So these are the number of grades that are needed for us. So now what we'll do is, so now what do we want to do? We want to traverse this input array. We want to fulfill our condition as much like as many grades as we can get from each course, and then we want to move forward. Write essays. No, we definitely do not want to write essays. Right. Now what do we do? What will be the logic here? I want somebody to like say the logic. Guys,
Can we like keep increasing until the grade reaches 5 and go on to the next one? Something like that.
right, exactly. That's exactly what we want to do here. So
with that, we keep a check on the maximum average, maximum pointer that we can have.
right. So we check the number of grades that we can get from here. Either this will be the number of grades that are needed, and this will be a minimum of these two. Does this make sense? Yes. Does this make sense? This is like what we want to do here. Does this make sense for everyone? It's okay, Rishabh. You will get a lot of questions to think about this. It's okay. When you will be able to solve div 2C question in like 5 minutes. Like this one is a easy question. Otherwise, like if you can solve div 2C question in 5 minutes, that is like a very good state. So Google asks the level, like the level of questions will lie between div2c and div2d. Div2d are really hard. Definitely, if you practice a lot. It's all about practice, guys. It's all about practice. There is no other magic. Does everyone understand this question? Any doubts?
मैम अगर इसमें लैम्डा फंक्शन यूज कर सकते थे?
हाँ, लैम्डा फंक्शन तो तुम कहीं भी यूज कर सकते हो।
मतलब उसके लिए फिर वेक्टर और वेक्टर नहीं बनाना पड़ता?
नहीं, तब भी बनाना पड़ता ना।
मतलब एंड पास कर देते तब भी बनाना पड़ता?
तब भी बनाना पड़ता, तो वही प्रॉब्लम थी, राइट? सो दैट वाज द प्रॉब्लम। सो लैम्डा फंक्शन कुछ नहीं है। लैम्डा फंक्शन इज, जो भी तुम लैम्डा फंक्शन में लिखोगे वो तुम यहाँ पे भी लिख सकते हो। लैम्डा फंक्शन इज जस्ट एन एनोनिमस फंक्शन, यू आर नॉट गिविंग अ नेम टू दैट फंक्शन, दैट्स इट। प्रॉब्लम है कि उसके अंदर लॉजिक क्या लिखोगे। तो do this, try solving it using a lambda function. Try solving, like create two vectors and then try solving one vector based on the other vector. So I'll write down the steps for you. So this is what we actually like. Right. So we can actually like put a break statement here. So the problem lies in this third point. So if we have both the vectors with repeating elements, how do I identify the index for the other element in the other array? If I have a way of doing that, then I can do this like we did in the last question. Otherwise, I cannot. Lambda function is just another function with no name that you just write in line. That's it. कुछ hard and fast rule नहीं है उसका. First for loop. First for loop. Does everyone understand this for loop now? So the previous syntax, what it does is, so that is called an for each loop. So you guys can Google and read about it. That is like another syntax of for loop. That's it.
Ma'am, can you explain that problem with taking two separate vectors again? That third point that you've written.
Okay, let's. Let's say we have these two vectors, right? Now I want to sort this grades vector based on this essays vector. So what does this mean? This means that, let's say, so if I had these grades and essays vector, then if I compare these two elements 3 and 4, then I want to put 4 before 3 because 1 is smaller than 2. Does this make sense to everyone? Number of essays needed to write 4 is less than number of essays needed to increase 3. That's why I want to put 4 before 3. So I need to compare these two elements 1 and 2. Does this make sense?
Yes.
So now, in order to, like, while I am sorting this array, this grades array, if I want to compare the elements from essays array, I need to have the indexes of these two elements. So let's say somehow I store the indexes of all these elements. Do you remember the last problem that we solved yesterday? We created a vector of indexes.
Yes.
So what we can do is indexes of 1 is equal to 1, 2 is equal to 2, and so on. We'll have an indexes array like this. Does this make sense with me till here? Now, let's say I wanted to sort this grades array. So now I got these two elements, 3 and 4, and I want to compare the elements in the essays array based on these two elements. So what I'll do, I'll go to this indexes array, I'll find the index of these two elements, and I'll compare the essays of 3 and essays of 4. Does this make sense? Does this make sense, guys? Now, let's say I put a 3 here also. So indexes of 3 is just not 3. Indexes of 3 is 3 and 4. Now I could have a vector for this. Like, these elements could be a vector also. But how will I know whether this particular 3 that I am trying to sort right now belongs to third position or fourth position? There is no way I can know that. And I will not be able to find the index, then I will not be able to find the corresponding element in the essays array, and I will not be able to sort this array based on the essays array if this particular array has like non-distinct elements. Is this clear to everyone now? Right. So guys, I think that's it. I think some of you have a meeting at 12. So either we can wrap it up here, or I have more questions, but I think it will make more sense now, like if you practice those questions yourself and then we discuss it. So you know all the tricks now. Like basically, like these are very simple question based on sorting. You know how to write a comparator function for 2D arrays, for multidimensional arrays. You know how to like sort based on a particular column if you want to sort. The algorithm will change if you are sorting on the 0th column. If you are sorting on the first column, the algorithm will change. And we know how to sort one array based on the other array. the first array that we are trying to solve needs to have the distinct elements. If it does not have distinct number, like if all the elements are not distinct, then we cannot sort it using like this array based on the other array. We need to merge these two arrays to keep track of the indexes. Does this make sense?
Can you please scroll it?
Yes. So we learned selection sort, we learned insertion sort, we learned counting sort, we learned bucket sort. I hope those 4 algorithms are clear to everyone. Is there anyone who has any doubts in those 4 algorithms? We learned how to write comparator functions and how to use those comparator functions to solve problems. We saw a few problems, how we can like sort the input and make our lives easier. So one pro tip here, generally in the input array, like if you are given an array and if you are using an algorithm of the order of n log n, generally if the input size is not like very large, n log n will work fine. You don't need to optimize it to n. Always use the sort library. If you want to sort the input array and you are not going to sort count, like if you are not using counting sort, just use this library sort.
Now for counting sort, we can use it max minus min, right?
Yes, if you are implementing counting sort, you have to implement that implementation only.
Can we do binary search and insertion sort?
When we do binary search and insertion sort, we discussed that yesterday also. So even if you do binary search to find the position, you will find the position. Then also you will need to shift all the elements towards the bin, which will take O of n time.
Okay.
So it's so binary search is so that is like actually a very good understanding. Like if you guys can so whenever you see a sorted input, like think of like if you want to optimize the algorithm, think of how you can fit binary search into that, like based on the predicate, if you can like create a predicate out of it. So but don't just sort the input randomly. Sometimes it might not be a very good choice.
I'm like in binary search and insertion sort, we just have to find the position where to insert the element and then just swap it, right?
Sorry, no, we can't
Like,
swap it, right?
because the preceding elements will already be sorted, right, in insertion sort.
So if I have now I want to put this 3 into its right place, which is here. So if I just swap this 4 or 3 or just this 2 or 3, then like this element will not be in its right place, right?
Okay, okay, okay.
Okay guys, so let's call it a day. Thank you. Does anyone have any other questions? Thank you guys. Stay safe. These are difficult times.
Hello,
Stay indoors, stay safe. Yes.
ma'am. Can you tell on basis of the input data, when could we use insertion sort and selection sort? Like if we had a smaller range, we used a counting sort. Similarly, is there a pattern in data which we can see to decide when
So
to use
you
which?
will almost never use these two algorithms. Never. Almost never. But you might use the tactic that we used in insertion sort in some to solve some of the questions. So it was kind of important to know that algorithm. So so basically like this algorithm, so insertion sort, you need to learn this very, like you need to understand that we keep one half of the array, like one part of the array as sorted and the other part as like unsorted, and then we like put the elements from the other half to the first half. This invariant is important to understand. So you will almost never use these two algorithms, but these two algorithms are important to know to appreciate the better sorting algorithms.